Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 146, Subsequences with a unique middle mode 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one I made two wrong answers, but the first one was silly, the second one was just also silly, but it was kind of more that I got a little bit lazy and I did the math wrong. Or I just copy and paste the math and I was like, oh wait, that's not right at all. But, but overall, honestly, this problem is it's not easy, but it is simple, right? And what I mean by that is that it is just case enumeration. There are different ways you can implement this in a cleaner way. I think Alex Rice has a very good. Let me actually find that real quick. He definitely has a cleaner code in the whatchamacallit. Oh. Hmm. I don't know how this works. But in any case, he has a much cleaner code, but I am just going to go over mine. The idea here is case enumeration, right? So then now it's just having a for loop over the middle element, right? Because it has to be the middle and then it has to be a mode. What does a mode mean? Well, a mode of 5 elements can only be a couple of cases. It can have, well, 5 of the same element, 4 of the same element, and in this case, you're given the middle element, so you mean 1 to the left, 1 on the left, 2 on the right, 2 on the left, 1 on the right, and then that's it, right? 3 of the same element, same idea, right? You have 2 on the left, 0 on the right of the same number, 0 on the left, 2 on the right of the same number, or 1 on the left, 1 on the right, right? Pretty, yeah, still reasonable so far. The only tricky thing is the 2 of the same element, right? When there's 2 of the same element, this is where it gets a little bit tricky because, well, I mean, you can still do the case on 2 on the left, 0, or actually, sorry, I messed up. 1 on the left, 0 on the right, 0 on the left, 1 on the right. But the problem is, and this shows up on the one of the examples in this one, is that there could be another 2, right? So that's basically the idea, is that you enumerate all that. Is that okay? For each of another element, subtract out the ways that there are 2 of those elements or 3 of those, right? And yeah, and that's pretty much the idea for both of these, really. And yeah, and even for this case, you have to separate them out, but yeah, because basically here, you can have, say, let's say this element is A, and this element is B. Then you can have, let's say the middle is A. Then you can have A, B, B, and then some random C. And the order doesn't matter in between the left and the right side, just to be clear. But yeah, and then you can also have A, some C, A, B, B, right? So, and then yeah, and that's really the idea. You can also, of course, have 3 of them, which is just, in this case, that'll be A, B, A, B, B, right? Because the extra A is on the left side and is what we have. And then on the right side is the same thing, right? Except for that, it's just on the right side, right? Because then now it's B, C, A, B, right? B, B, A, C, B, B, A, B, right? So yeah, so those are all the cases, and once you kind of subtract these out, then it all works out as long as you do the math right. That's really the core part of it. It is, like I said, this is simple, but not easy, because it's annoying to get right? That's why, not many people got this one. But as you can see from my brief scan of the code, and we'll go over it, don't worry. Yeah, it is ridiculous. But it is what it sounds like, right? Okay, so yeah, so I actually want to optimize this a little bit. So L here is or make it more readable. So L is number of X, which is our current thing, on the left of the middle element, right? R is equal to number of X on the right of the middle element. But I also want to add in a thing for, like, maybe L rest is equal to number of non-x on the left of the element. And so LS would be just be I minus L, right? And you kind of just work this out. I mean, I think, and all rest is equal to number of non-x on the right of the element, which is yeah, going to be n minus I minus 1 minus r. And again, you can work this out slowly. I mean, I think it's not that bad. But yeah, and then now it's just case analysis. If they're 5 of a kind, almost like a poker, if they're 5 of a kind and there's 2 to the left, 2 to the right, then it's just left choose 2, right choose 2. 1 left, 1 right, you have these things. And yeah, and here, this should be rest, right? And this would be L rest. And yeah, 2 left, 1 right, then you have 2 on the left, 1 on the right, and then the rest you have to choose 1 element. So technically, if you really want to be precise, and actually I actually wrote it out this way, but you can write choose 1, right, which is going to be R rest, and same thing for here, right, for the rest of the numbers on the left side. And here is the same idea, right? Maybe it's a little bit easier if I just write this out like this. I don't know if it's true, but I think like it just yeah. Right, so maybe that's a little bit easier to understand in terms of just keeping everything consistent, right? Because now you have L numbers to choose from 1, or to these are the number of x's on the left side, number of x's on the right side, and then just like other numbers on the left and any other number on the right. And keeping in mind that if you have 3 of a kind, there's no other. This will be the mode, right? There's no other way to go about it. And yeah, and this. And I don't know if I'm doing that much of a surface in explaining line by line, but these are just the case analysis, right? So you have 2 to the left, so then the 2 to the right of not x, right? And same idea here. And the 2s are where it gets a little bit tricky, right? And maybe again, to keep in notation, on the left side we choose 1 of L, and then yeah, and then something that's not an x. And then on the right side, we choose anything that's not an x, right? So that's basically how this comes to, right? And then now, because as we said, this takes 2 of a kind, but we have to subtract out the cases where that's not true because we overcount them. And because n is equal to 1,000, we are able to enumerate all the other cases, and that's the idea, right? Because this is another O of n loop, because you have at most n unique elements. And then if they're not equal to x, and this is, I don't know, maybe it's inconsistent with the b and the x. But yeah, we do a binary search. Oh, I think I skipped this, sorry. But yeah, we have an indices that of x that just gives you, for every x, we append all the indices for that x. And of course, that just allows you to, yeah, do a binary search on it, on the I, where the I is the middle element that we're trying to look up for. And yeah, and LB is the number of B's to the left of the current element, and the number of B's to the right of the current element. And that's really the idea behind this, right? And you could work these out too, though I kind of made a mistake here before. But yeah, here again you can add the choices to make it a little bit more clear. But yeah, and here this is L rest minus that choose 1, right? And you can maybe add a variable here too, but basically these are all the things that are not x. So then minus b is to get anything that's not b or x, right? So that's basically the idea there. Here again, maybe this is a little cleaner, but really, like I said, this is all just case enumeration. So I don't really, yeah. And this is R rest minus RB1, right? If we just choose 1. Yeah. But that's pretty much it, the idea. And then we do it on the other case. So there's a lot of symmetry here. You can kind of, just kind of work that out. But and you could even look at this and this, and you see that there's a lot of symmetry because, well, there should be, right? Yeah. And yeah, I mean, I know that maybe I'm not explaining it that well, honestly, now that I think about it. But like I said, this is just going through the cases and then doing the math. If you do not understand the combinatorial part of it, let me know in the comments. But I think, especially for this, I guess it is part of the entry. There's really no no way about it. Maybe did I? No, this is all right. Okay, fine. Yeah. Right, and that's pretty much the idea. You know, you just kind of do a lot of choice things. Give it a quick submit just in case I am being silly and made a mistake, which is possible because we wrote a bunch of stuff. Also, it'll be funny with timeout because of all these combination calls. You probably could, you know, yeah. But in any case, yeah. I mean, I'm gonna scroll through it again in a smaller way, but I don't really have much thing to say, right? Like, it's just case enumeration, and that's pretty much it. Like, I don't really have much to add to this one. Yeah. So this is the top, and this is the bottom. And yeah, and that's all I have for this one. Let me know what you think. This is gonna be n squared because this loop is O of n, of course, and this loop is O of n, so that's gonna be n squared. And this loop as well, but it's, you know, it's not it's just n squared loop for the left side and the right side for the symmetry about this section. But yeah, that's it. Thanks for watching, and yeah, you could watch me solve it live during the contest next, but it's just me going really slowly doing what I just did, so I don't know. But yeah, thanks. Okay, we're usually make mistakes. I mean, a little bit cheating because we see that, you know, in the virtual contest, we see only 88 people got it accepted, so this is a very hard problem. I am curious about the leaderboard, but there's no leaderboard link anymore. I had to kind of finagle the URL for it. And my watch is telling me to stand up, but it's okay. Wow, people are fast. 140. Oh no, that's right. I forget that this is at the very end because they don't. It's not live. So 147 is the lowest rank I could be, which is nice, I suppose. But okay, we have to finish this. Oh yeah, mod. Given the way subsequence of number 5 with unique middle mode. What is the mode? Unique mode if it only has one mode. Unique. What is a middle mode? Oh, if middle element is a unique mode. Okay. That's a funky one. What does a mode mean? Well, first of all, I think 1,000 numbers only though. Maybe that could be a hint. I don't know if we need a sort, but it's fine. Okay, for each... Oh wait, no, you can't sort because the middle element has to be... Okay, so the order does matter to a degree. Okay, so let's say we iterate a number in the middle, then what does that mean? What does mode mean? Mode means that we want at least I guess it's just case enumeration if I have to guess at this point of yeah, I think it's just case enumeration of, okay, so for each number that is the mode, you just count the number of left things and then combine them, right? The only tricky thing is that you can have 2-2, which is the only tricky thing. How do you prevent the 2-2 cases? Okay, so how do we do the count? I mean, it's idea is easy, but I don't know that it's easy. Okay, right. So we have the middle number. We count. The number of numbers that on the left and on the right, and we just do a lot of combination stuff. I think the one tricky case about n is equal to 2 is hard, I think. I don't know, but all right, we could get started though. So here maybe we have only 1,000 numbers. Only which means that we should be able to do prefix sum in a good way, right? Yeah, I mean, okay, just do it, Larry. I guess you could always also do binary search. Yeah, maybe that's actually a little bit cleaner. I don't know if it's true. Okay, and then now I don't know how to do the 2 case though, but we could, okay, just focus on getting it done, I suppose. Or like one step at a time. Let's focus on the things that I do know, right? So okay, so then now 5 2 to the left, 2 to the right. Okay, so then now so this, it means that, yeah, okay, so that means that to the left is going to be just index, and then right is going to be link for okay. Okay, so then now we want L choose 2 and R choose 2. Okay. Right, and then that's, I don't think, I mean, this is clearly incomplete, but it actually should work for the first one in theory. Okay. Okay, so that's good. Yeah, this is the tricky part I don't know how to. Oh, I see. They want you to, so the 1,000. Is it just L choose 5? Or is it just this choose 5? Maybe I'm being a little bit too fancy with this. That's wrong. Why is that wrong? Why is that wrong? Choose 5. So we have 6, choose 5. Is that not right? Why is 6 choose 5 not right? 6 choose 5 is 6. Okay, so 6 choose 5 is right, but I'm just doing... Oh, well, that's because I'm doing it this way. Whoops, I forgot. Actually, it should be for x and index user keys. Maybe I'm doing this one though. Yeah. Okay, so that's right. And then now we want to choose 4. Okay, so these are the 5s, right? So maybe it's just less complicated this way. And 4 is just choose 4 times 1 of every other number. So basically it's going to be n minus c, right? Okay, and then 3 is going to be choose 3 and then n choose 2, right? Now it has to be n minus c choose 2, of course. Okay, yeah, I think that's fine. And then now the hard part is the 2s, right? Well, that's okay too, I think. I think this is the only part that's hard, in theory. Choose 3, so this is going to overcount. We know that. Now we just have to subtract that out, right? And we want to subtract that out by... Yeah. Okay, so now you want to do... I don't know. So, okay, so you have all these, you want to choose 2 times the way to choose that we choose 2, and then times it by any other number, which is going to be n minus yc minus yc. Choose 1 technically, but I guess that's the same, right? Is that not right? I mean, that doesn't seem too hard if that's true. Okay, well, it's already wrong, but so oh well. Oh no, this is subtract. This is subtract. That's why. Is this it? I don't get it. Only 88 people, so I don't feel like this could be right. But okay, let's YOLO submit. Maybe I'll get a wrong answer. Okay. Negative number, but that shouldn't matter. Expected 1 0. Oh, it has to be the... I think I messed... Okay. I forgot about the middle part. I forgot that it has to be the middle element. Okay, that was... I was thinking about it, but I just forgot. Okay, 4. I guess the reason why 4 works is because of the... No, that I was going to say pigeonhole, but that's not even true, is it? Because you can definitely have a case where... Wow, I'm just really bad today at reading. Like one. So that's why I had it the other way when I started it. But, okay, I guess I just have to rewrite this one. That's fine. I think we have some ideas about it, but, yeah, okay, fine. I mean, I thought that felt too easy. I was like, I don't get it. What is wrong here? But, oh well. Yeah. What did I have? Okay, so... That, okay, so then column L choose 2 times. Okay, I mean we have to figure out how I mean it's gonna be similar, but I don't know. Let's just comment this out. Okay, so that's the way to do 5 where it is the element, but 5 is actually pretty easy in that way, because I think it actually I did not need to do this, but okay, but for 4, so this is for 5, right? And then now for 4 we have 2 left, 1 right. So here we want 2 left, 1 right. I know that's whatever, but okay. And then one of any number that is not R on the right side, right? So that means that on the right side, it's going to be n minus I minus 1. And minus R for, we cannot choose those, times, no, that's it, right? Because you only choose 1. I guess technically it's just choose 1. We want to be more precise, but okay. And then 4 to 1 left, 2 right is going to be the same. How does this look? A lot of people got wrong answers. Okay, so it's still gonna be tough. Choose 2. Then now on the left side there should be I elements, right? Yeah, I elements minus L, and that's it, right? I mean, these are going to give me crazy numbers, but that's fine. Well, it submitted this, it's fine, whatever. This should be 0, but this gives me 7, which is actually not great. Why does this give me 7? 1 is 6. Okay, let's debug this while we can before we do the other ones. I thought it was case enumeration, but yeah. Okay, so it's the 4s that are so at index 3, so 1, 2, 3, so this one, it wants 1 number to the left and then R to the right, right? Okay, let's put more. So it is this one where it wants this, but why? It's 3. R is 3. Why? No, this is an n, that's why, because this is length of indexes of x. I am being a dumbo. Okay. Okay, now we're good again. Yeah, okay. Okay, and then we want to use the example of just I don't know, 1, 5 or something. That should give me 1 if everything goes right. Yep. Maybe we add another one. That should give me 2 maybe. Yeah. Okay, fine. I think we're okay now. Or more okay. I don't know if we're okay yet, but okay. So then now it's just 3. How much time do I even have left? An hour left. We're okay. 3, 1 left, 1 right, right. Yeah. Okay, yeah, that sounds right. And then times by I minus L times. Okay, right. So those are the things for 3. How do I not double count? Do I double count? Oh, because these will be 0. That's why. Okay, that's fine then. Larry, you're so smart. No, I'm just kidding. But okay, and then now just 2 left. So this is going to times everything on the right. So comp choose 2, right? Okay, and then it's gonna be the same idea. I choose 2 times comp of choose 2, right? Okay. 6. It's 6, right? I guess so, actually. Because this I didn't count stuff like this, and that's already 1, 2, 3, 4. There's 4 of them, right? That are length 3. Okay. Now length 2 is the hardest one, I suppose. I think we just do the math and then length 2 means that they all have to be different. That actually sounds easier to do, right? Okay, so we choose 3 different things and then we no, that's a tough math. That's an n cube math if you want to do, because it's not just those 3. But can I do the contribution math on it? So okay, so you have to do, and it's not even that, right? You have to choose 3 different numbers, but that's fine. That part is easy. But then you have to multiply it by the number of ways to choose those. That part is hard. So it has to be 3 different numbers. Okay. It's either that or maybe it is just case analysis then. Okay, so if we do every possibility, then what happens? Then you have to subtract out on the right side. That's hard. Okay, maybe that's why. Yeah, maybe. Okay. How do I do this one? I mean, can we enumerate the cases? But then we have to we have to be careful. Okay, so the two case is the two case. What is the two case? I mean, we can subtract out, but okay, no, I mean, I think that's fine. I think we just have to do math on. Okay, yeah, maybe. Maybe, I don't know. We'll see. Just want to make sure I'm not double counting. Okay, so you have 1 left, 0 right, fine, right? And just comp of. Do I need to separate the left side and the right side? I guess so, because we have to keep it in the middle. Where's that? I minus L, choose 1, so I guess that's actually just this. Times. I need more better variables. I'm gonna mess up on a typo and I'm gonna be like really sad. Okay. Yeah, we just choose any two. And then we just have to subtract it out, I think. Okay, fine. And then the right side, it's gonna be right side. Something like this, right? And then now we overcount. So, it's a mess. It's a mess. I think I know how to do it, honestly. It's just so annoying to do, and I'm trying to think about it. Yeah. Just for consistency's sake. And then now we'll just subtract it out. Both the case where one number, there's 3 of them. Okay, so then now we want the case where okay. So this is going to be the number that is on the, okay. So that means that on the left side of something like that, right? Okay, so that's number of things on the left and number of things on the right. So we have to subtract out. This is so annoying. I mean, it's not that bad. We have to subtract out. Which one is this? 2 on the right. So we have to subtract out 2 on the right. I guess we can actually do these together, but I think my head is too dumb for this. Yeah, I mean, okay. So it's just RB choose 2, right? Choose 2. And then number of left side, right? Okay, so these are the 3 of B's. Maybe there should be Y's. Okay, 2 of B's is going to be 2 on the right, right? 2 on the right, and anything on the left, which is going to be I minus L minus LB. I think anything else rather. So then now this is what 1 on the left. So that's just gonna be LB is the one. RB is on the right, and then you have an extra floating one on the right. So that is going to be, that's the total number of numbers. I should have used an SOA variable for this. It's too late. Is it? I don't know. Okay, well, I think that's good. And then now we just do this here, even though it should be, I could probably keep on the same loop, but I think mentally I need that separation. So 3 of B's, it's going to be okay. On the left side we choose 2. 2 on the left. So it's actually, this part is actually not that bad, right? Maybe it is. It's so easy to make a mistake actually. 2 on the left. And then on the right side is 1 of anything, so it's going to be whatever's left on the right side. So this is the number of things minus R minus RB, right? And then on the right, yeah, okay. 1 on the left, 1 on the right. I guess this shouldn't change. Does that? No, that doesn't double count, I don't think. Okay, I don't know. I don't know if this is right. Let's run it real quick. Com n must be a non-negative number. How do I get? Am I off by 1 on my index? Find select left on I. Oh, it could have no elements. I suppose. Am I bad at binary search? I mean, yes, but so it should give me the next integer, and then okay, maybe I don't need a -1. Maybe I just get confused. Okay, well, this is how we do it. Line 46. RP. I guess we just. Oh, there's no negative -1 because you cannot be the numbers cannot be exactly in the middle. I think I just in my head did something similar. Okay, am I better? Okay, the answer is no. I mean, this is definitely not right. We twice over subtracted. Am I over subtracting something? Do I need to like add something back in. What's this one? Is this one? This should be 0, but I have this ridiculous number, which is, what is the mod? So that's like -2, I guess. But we could debug that, so that's not that big of a deal. This one being 4, this one is probably more interesting for me for now. How much time do I have left? 45 minutes. Okay, so we don't this is too annoying too. If we don't subtract the overcount, is it at least correct-ish without the overcounting? 6, okay, so it overcounts correctly. Does it? There's 4. And the 2 instances of this, so okay, so yeah, no, that overcounts correctly, so I'm subtracting it incorrectly maybe, or maybe I'm double counting something. I don't know. I mean, this makes it right, but why? So this should, for this, okay, so this 2 should have, no, this 2 should have a thing. Wait. And it's double counting because, does it double count? Let's see, what does it think it's doing? Okay, so it's not the 3 B's, which is true because we don't have 3 B's. Okay, 2 on the right, which is true, but that should only have 1 instance, right? So 1, 3, 2, so there's only 1 instance where that's the case. Did I do the math wrong? I is the number of numbers to the left, okay, yeah. And then L and LP. RB choose 2, it should be 1, right? Alright, let's take a look. This is unreadable, but okay. 1 negative. Okay, so -1 is the middle. I'm not looking at the right one anyway. Okay, that's why. Okay, so the 2 and the 3, there's 1. 2 on the right, and then there's this one, 1 on the left, 1 on the right. LP, what's LP? Maybe that's one. Silly mistake somewhere, I think. Okay, so the 2 and the 3. LB is 0, which is true. On the right side is 2, that's fair. This is 1, okay. But then, and then LB should be still be 0. I'm really bad at this. I really need better better debugging things. Okay, so this is 1. So why is this thing not? Wait, so then why do we subtract twice? Okay, So we do this thing twice. Oh, we double. Why does the first x? Okay, that doesn't make sense because we're subtracting it from a silly place where how do I take that out? Well, it's just because there's no two numbers on the left, right? So actually, I think this is dumb. It should be starting from Okay. Still 5, that's good. Because then here we can do. I didn't think the math would have worked that way, but okay. So now we fixed that one, but this one is still wrong. Which one is that one again? Oh, it's this one. It's so wrong. Is that -2? Okay. I mean, this is the only place we subtract, so -1 is the one in the middle. We subtract overcounting, but it only overcounts if we have we have to okay, maybe this thing is a little bit silly because I think I overcounted, but we can actually just do. Actually, yeah, no, I think the way that I'm doing it with the removal is a little bit silly. So what we can do actually is just do more case enumerations, right? Okay, so we have this thing. Okay, right? So then, okay, so then, one left. Okay, so on the left side you have this. So you need another random number on, but actually that's very annoying. No, it's fine. Come on, Larry, you could work this out. Okay, 3b's. It's gonna be this times 1 on the left. So that's it, right? Oh wait, this is. No, okay, yeah, this is that. Well, this is wrong. Okay, how do I combine them? A good way. So these are the things that are not right, but we want to subtract out. Why do I mean, I think this is, the idea is fine, but we subtract stuff without having enough stuff, which is very awkward. Okay, so how do we do this? I mean, is it enough to cap it? We count all these things. I think it's enough. I think I messed up anyway. So I think I need, for each one, I need to multiply by this, and I think that actually would fix it, because L is 0 in this case. Which is actually ridiculous. Okay. I mean, I think this is. I mean, I don't know if it's right, but I mean, it matches the output, is what I mean. So that kind of right, but not like confidently right. Alright, YOLO. Ooh, wrong answer. That took a while for a wrong answer, honestly, but okay. I output 1, it should be 0. I mean, that's true. So I think, so there is 1 because I do so this. Okay, so it is on this side or this side? Okay, yeah, so it's on this, which is that it has 0 to the left, 1 right. Okay, so that part is right in theory, but then now I have to factor into here. But this, so this is not working, seems like. Uh, 34 minutes left. Basically, this is returning 0, I suppose. Yep. And it should be on this one, so okay. Why? LP times 5B, right, that's good. 1, 1, 1, R is also 1. So then you have this thing. Am I just off by 1 here? No, there's no more numbers on the right. On the, oh, is this on the right? Okay, so, oh, this is just typo actually. One on the left, one on the right. This doesn't make sense, does it? One on the left, one on the right, and then everything is on the left, right? You have the 1 extra number on the left. So that is actually wrong. There should be I minus, I went too fast on this one, I suppose. But if that fixes it, then I am happy. I mean, we wrote so much code that if that was the mistake, that is not bad. I wouldn't be surprised if there's like 5 more mistakes we have to fix. Yes, we got it, friends. I mean, this is a hard one for sure. Like I feel I feel happy about this one, I think. And because it still took like 45 minutes or whatever, plus 2 long answers. But I knew it from the get-go how to do it, but I just didn't want to do it that way. That's why like my structure was kind of right. But yeah, I mean, okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, this explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.